From integral calculus, you know that if f of x is a continuous function over an interval ab, then the fundamental theorem of calculus says that integration from a to b f of x with respect to x, that will give us an antiderivative, or we can say antiderivative. It will be finally f of b negative f of a. Antiderivative at upper limit, negative antiderivative at lower limit. This is called fundamental theorem of calculus. Okay, this is going with math 120. So this concept is again helpful here because we are going to start complex integration, or we can say complex integrals. It has another common name, contour integrals. So here in complex integrals you will see some patterns. You can see here we have y equal to f of x. Both x and y are real variable. That means f of x, this is real valued function. But if we have a function f of z, z is a complex variable. Z can either be x plus yi, or in the form r e to the power I theta. So now we can easily say that this function is a complex valued function. So if we have a complex valued function and we are targeting for evaluating the integral of this function f of z over a path, this path is written as c. I am mentioning this one path. Okay, so we are going to evaluate the integral over a path. This path may be a curve, it may be a straight line, it may be a circle, anything. That means it may be linear, it may be non-linear. Under this path, what will be the integral? Let's say this is integral I. We need to evaluate this integral. The formulas are totally going with real valued functions, but we need to understand how we can evaluate this one. So here z is the complex variable. So at first have a look on the types of complex integral. That is, it may be in f of z dz, or it may be in integration from z1 to z2 f of z dz, or another type will be integration from x1 y1 to x2 y2 f of z dz, or another common form will be f of z dz with this. Here we have c. Instead of c, it may be written as this closed integral. Okay, so these are the types you will see in complex integrals. It is apparently looking different. That is, first integral is different than the second one, third one, and fourth one, but actually the process of solving is same. So at first, let's recall how we can integrate. Suppose we have integration x cube dx from 1 to, let's say, 4. So you know that integration of x power n dx, that is equal to x power n plus 1 over n plus 1. So here we have a restriction, n can't be -1. Okay, just think about this. So it will be integration of x to the power 3, it is x to the power 4 over 4. And by the fundamental theorem of calculus, you can see that if we have the antiderivative finally, then we need to input upper limit at the antiderivative, negative lower limit at the antiderivative. Okay, so if we do the same thing, we have upper limit 4, lower limit 1. Now we need to input upper limit where we have x, lower limit in the place of x. So that means it will be actually 4 to the power 4 by 4 negative 1 to the power 4 over 4. So actually we are getting, here we are getting 4 cube negative 1 over 4, and you are getting the result. So this is how we are practicing this integration. Okay, and the same thing is applicable for complex integrals, but you can see that in real valued function we have x equal to 1, x equal to 4. We are integrating in terms of x. That's why we have the variables, we have the limits for x equal to 1 and x equal to 4. We can also integrate in terms of y, because in math 120 you have learned this concept. So before starting complex integral, you have to recall all these things. So let's say now we have y squared dy, or let's take a trigonometric function sine y, integration from 0 to pi. So here, or let's say pi by 2, integration of sine y in terms of y. So you can see that here we have the variable y dy. So that means the limits at this moment is for y. So here, integration of sine y, you know the formula, it is negative cosine y. This is the antiderivative. So by fundamental theorem of calculus, we can easily evaluate the result. That is, we can pull out negative at first. So pi by 2 0. Now from this one, what we can write? Negative cosine, where we have y input upper limit cosine pi by 2, and there is a negative from fundamental theorem of calculus cosine 0. So negative cosine 90 degree, that is, you know that it is 0, and cosine 0 is 1. So you are getting 1. So this is the result for the integral. So be sure that we can integrate in terms of x, we can integrate in terms of y. So this thing is important in complex integrals. We have to keep only one variable, either x or y, then we can integrate. So since in complex valued function f of z, we have two variables at the same time, z equal to x plus y I, x, y are the variables, or in polar form r e to the power I theta, that means r and theta are the variables. So actually we have two variables at the same time. So we need to convert these complex integrals to real integrals so that we can easily integrate or evaluate these integrals. So can you hear me properly?
Yes,
Yes,
sir.
sir.
Okay, so our first target is to convert whatever type we will have. We need to convert all these types to f of x dx or f of y dy, so that we can have only one input variable, that is either x or y. If we have f of x, then we are integrating in terms of x. We have f of y, we are integrating in terms of y. So whenever we have f of x, you are sure that there will be lower limit x equal to, let's say, a, upper limit x equal to b. That means the limits will be for x. For f of y, the limits will be for y. Let's say it is y equal to c, y equal to d. Now, have a look on the types. A complex integral may be in this form. We may also have some other forms, but at first try to understand these basic forms, how we can integrate this type of integrals. Then we will move to the complicated parts. So here you can see that z1 is a complex number that is taking x plus yi. So here we have x and y. Similarly, the same thing is for z2. Or if we have a look on this, so you can see that we have a point instead of only one x, that is x equal to x equal to b, we have x y, or x1 y1 x2 y2. We have two values. That means the point are here. So it's quite difficult to integrate this type of integrals. So that's why our first target is to convert all these things to our known functions, that is f of x or f of y. So our target should convert f of z to either f of x or f of y, so that we can easily integrate all these things. I'm mentioning this is the procedure, how we can integrate complex integrals, or we can say what is the solving technique. Suppose we have any of the form 1, 2, 3, 4. So the forms are looking different. The solving technique is same. So at first have a look. Step 1. In step 1, you can see that we have either z1, z2 or x1, y1, x2, y2. So you know that any complex number z that is equal to x plus yi, we can represent this complex number in this form xy. That means a complex number is a point in Argand diagram. So a complex number is nothing but a point. So that's why z can be written as a point xy. Similarly, z1 is actually x1 y1, z2 is actually x2 y2. This is the alternative form. So that means any complex number can be written as a point. So first of all, let's say we have 2 points x1 y1 and x2 y2. So our target is to find the limits of integration. That is, we need to find either for x or y. We need to find x limits or y limits. But we can't keep both x and y. So that's why what we have to do, we need to check. Here we have z1 and z2. We need to check which variable is changing, x or y. The variable that means if x is changing, you will understand if we move to a problem or example. But for now, try to understand that if x is changing or x values are changing, then if x is changing and y is fixed, remember x1 and x2 are different, but y1 and y2 are same. This is the meaning that if x is changing but y is fixed, at that time x will be the limit. Similarly, if y is changing and x is fixed, then y will be the limit. If both x and y are changing, then both x and y have the ability in placing here. That means both x and y can be the limit. But at that time, we can take only one, either x or y. Step 2. So suppose we are confirmed that what will be the limit. X equal to 1 or x equal to 2 will be the limit, or y equal to 0, y equal to 4 will be the limit. So that is sure in step 1. Step 2. So we are thinking about Cartesian coordinate system. That means rectangular complex number. That means z equal to x plus yi. So from this part, we need to input either the fixed value, it may be x or y at first. Then we need to find dz, because don't forget that we have dz here. At first we have confirmed the limit, then we are finding dz, then we can evaluate the integral. So from z equal to x plus yi, whatever the function you have, your dz will be evaluated from the base form z equal to x plus yi. So from this part, find dz by differentiating. Step 3, the integral that you have, f of z dz, that will be automatically converted to f of x dx from x1 x2 or y1 y2 f of y dy. That means from this complex integral, you will get two forms. If x is the limit, then you will get this one. If y is the limit, you will get this one. And you know how to solve this one. That is, if we have integration from x equal to 1 to x equal to 4, x cubed dx, you can easily find this. Or if you have function for y and you are integrating with respect to y, you can easily find the result. So this is how we can solve any complex integral. Okay, so try to understand the procedure at first. We will follow 3 steps. At first step is to find limit, lower limit and upper limit, finding limits of integration. Here we will find dz, and lastly we will evaluate the main integral. So let's have a look on an integral. Suppose we have to evaluate, let's say we have z squared plus 3z dz. So we have a contour C, or we have a path C, where C is defined as, let's say C is the straight line from 20 to 22. That means we have to evaluate this integral, where C is the straight line from 20 to 22. So we can easily figure out these points in Argand diagram, that is 20, 1, 2. So 20 is here, and 2, 2, 1, 2, 1, 2. So we have a path from 20 to 22. Try to understand the orientation. At first, the starting point is 20 and the ending point is 22. So the straight line is this one. So we have a path from 20 to 22. Under this path, we need to evaluate the integral z squared plus 3z. So actually, we have, instead of c, now we can write 20 to 22 z squared plus 3z dz. Now it is going with the types. That means it is going with the third type, integration from x1 y1 to x2 y2 f of z dz. So now our first target is to understand what will be the limit. So step one, you can do all these things in your rough pace. So step one, that is, here you can see that we have 2 points. First one is 2 0 and another one is 2 2. Let's try to figure out what will be the limit. So you can see that in first point you have x equal to 2, y equal to 0, and in the second point you have x equal to 2, y equal to 2. So you can see that out of these 2 points 2 0 and 2 2, let's try to understand the chains of x or y, x and y. You can see x equal to 2 and x equal to 2. So x is not changing, x is fixed. But y equal to 0 and y equal to 2. So y is obviously changing. Is that okay? Do you understand my point?
Yes, sir.
So what will be the limit? X or y? Limit will be x or y? Can you please tell me?
So why?
Yeah, obviously y will be the limit. So that means lower limit will be 0, upper limit will be 2. So this is, yeah, any problem? Have a look on the theoretical part again. If x is changing, then x will be the limit. If y is changing and x is fixed or constant, then y will be the limit. So in our case, you can see x is 2 for the first point, x is 2 is for the second point. That means x is not changing, x is fixed, x is constant. So obviously x will not be the limit. But y equal to 0 and y equal to 2. So it is coming from 0 to 2. So y values are changing from 0 to 2. Is that okay? So limit will be this time y. So since,
Yes, sir.
yeah, so since we are now sure that limit will be 0 and 2, that means y will be the limit. So obviously this function that is for z, that should be converted to only y. Is that okay? Otherwise integration is quite difficult to solve. At the same time, dz will be converted to dy. Then we will get all these things, that is integration from y equal to c to y equal to d, f of y dy. You can see that we can integrate only for single variable x, single variable y. That is the target. Since complex valued function deals with z equal to x plus yi, so here we have x and y, two variables. Our target is to convert to only one single variable. That's why we are finding the limits of x or y based on the change of the variable. Since x is 2, x is again 2, so x is fixed, so x will not be the limit. If y equal to y is changing, then y will be the limit. You can see y is 0 and y equal to 2. So up to now we are sure that integration from 2 0 to 2 2 z squared plus 3z dz. So in next equation we can write integration from 0 to 2. That means we are integrating with respect to y. So y will be the limit. So still we have z squared 3z dz. Now our target is to focus on this and this. So have a look on step 2. Step 2 is saying that if we have z equal to, we have always z equal to x plus yi, that is the base form. So from this part, we need to find dz by inputting the fixed value at first. So let's try to figure out. So here we have z equal to x plus yi. So you can see that we have x equal to 2, x equal to 2. So we can keep x as 2 because we have the value for x. But since y is changing, y equal to 0 and y equal to 2, so y is still a variable. So at first we need to, before differentiating, we need to input the fixed value. Okay, so z equal to 2 plus yi. Now, if we differentiate with respect to this time, independent variable will be y. So we have to differentiate with respect to y. So d dy of 2 plus yi. So we are getting dz dy. Differentiation of constant 2 will be 0. Differentiation of yi, I is constant, and differentiation of y is 1. So you have just I. So dz will be I dy. So you can see we have dz equal to I dy. Do you understand my point?
Yes, sir.
And finally, have a look on step 3. So if we are done with step 1 and step 2, then in step 3, we have to convert this complex integral to our known form, that is of f of x or f of y. So you can see that we can do the same thing here. We are integrating from y equal to 0 to y equal to 2. Okay, now z squared. You know that inside z we have x plus yi. So it will be x plus yi squared plus 3z, 3x plus yi, and dz. dz is found to be I dy. Is that okay up to now?
Yes, sir.
Now, okay, we have already done so many terms with y equal to 0, y equal to 2. So let's keep only 0 to 2. That means it is the same meaning as y equal to 0, y equal to 2. No problem.
Sir, in the exam paper, should we have to write how we find the limit, or we can just write?
No, 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 no. You can directly solve. Okay. That's why I have mentioned earlier that you can do all these things in your side note for your betterment. Okay.
Okay, sir.
So you can see here we have x. So already we are sure that x is 2. Or from this table, you can see that x is 2, x is 2. So we can keep 2 here. So 2, and here we have 2. Okay. So it will be 2 plus yi squared plus 3, 2 plus yi. And we have I dy. Remember, I is constant. So what we can do here? We know that I is constant, so I can be pulled out before the integral sign. So we have 0 to 2. Now we can apply our algebraic technique, a plus b whole squared formula. So it will be 4 plus 4 yi plus y squared I squared. I am expanding this one. Okay, then we have 6 plus 3yi. Try to look closely, otherwise if I do mistake, try to make me correct. So here we have integration from 0 to 2. So 4. Okay, we can also add 4 plus 6, that is 10. 4yi and 3yi. Actually, we have 7yi, and I squared is negative, you know. So we have negative y squared. Am I correct?
Yes,
Yes,
sir.
sir.
Okay, now we can see that whatever integral we have previously, this one or even this one, that has converted to our known integral. Now it is going with your previous course, Math 120. Okay, so you can easily apply your basic integral skill to solve this integral. So this is how you can evaluate complex integral. So now integration of 10 is constant with respect to y, it will be 10y. 7I is constant. Integration of y will be y squared by 2. Integration of y squared is y cube over 3. Upper limit 2, lower limit 0. So now we can apply the fundamental theorem of calculus, where we have upper limit and where we have lower limit. That means antiderivative at upper limit, negative antiderivative at lower limit. So at first, try to understand this is our input, and the fundamental theorem of calculus says that input upper limit at the antiderivative and lower limit at the antiderivative, and these two part will be subtracted. So since we are solving complex integrals, so the result will be obviously complex number finally. Do you understand my point? Or
Yes.
even if we get lastly 2, it is looking as real number, but it is actually 2 plus 0i. That is also a complex number. So our result will be in the standard form, a plus bi or x plus yi form. So at first, let's input the value of upper limit, 10 times 2, 7i, 2 is squared by 2, negative 2 cube by 3. So we are working with upper limit. And there is a negative that is coming from fundamental theorem of calculus. And if we input 0 where we have y, so 0 times 10, 0, 0, 0. So we don't need to think the second part. So finally we have 20 plus, it will be 2, and that means 14i h over 3. You can keep your answer in this form, but since you have calculator, or you can do some algebraic manipulation, then you can convert your result a plus bi form. That is the standard form. It is best to keep in this form. Okay, it will be wise if you keep your answer in this form. Is that okay? So this is how we can evaluate complex integral. So have you understood this problem?
Yes, sir.
Okay. So similarly, we can solve some other problems. Let's think about a problem where x will be the limit. So let's say we have to evaluate we have a complex path, that is contour C. Hmm. Let's take the same integral. Okay, no problem. Z squared plus 3z. I'm taking the same integral, but this time the point is different, where C is the straight line from 2 to 0 2, where C is the straight line from, we are working with straight lines at this moment, But things will be complicated if we have parabola or some other curves. Okay, if we have some nonlinear curves, things will be complicated. But for the basic understanding, I am starting with a straight line. Then we will move gradually to the next level. So suppose we have a straight line from 2 point to 2 point. The problem is looking same as the previous one, but it is actually different. At first, try to look at the point. We have 2. So we have 2 point here and 0 2. 0 2 is here. So the orientation is from 2 to 0 2. Try to understand from this language part. We have a straight line from 2 to 0 2. In complex analysis, orientation is important. Try to understand where is the starting point of the path and where is the ending point of the path. You can see from 2 to 0 2. So obviously our starting path is this. So 2 to 0 2. So that means we can write this integral instead of c, we can write by this way. That is, here we have integration from 2 to 0 2 z squared plus 3z dz. Do you understand my point? We are gradually trying to solve this integral. At first we have c and we are converting this c to the points. That means we are mentioning the lower limit and upper limit. So lower limit is a complex number 2 plus 2i and upper limit is a complex number 0 plus 2i. Now from this part, our first target is to find the limit. So step 1, we have total 2 points, 2 and 0 2. So we will apply the same technique whatever we have done here. So try to understand again. X and y, sorry. Here x equal to 2. For the first point, x equal to 2, y equal to 2. For the second point, x equal to 0, y equal to 2. So now try to check. Here you can see that x equal to 2, x equal to 0. So x is changing at this moment for this integral, for this c. And y equal to 2, y equal to 2. So obviously y is fixed. Is that okay?
Yes, sir.
So theoretically, we have written previously that if x is changing, y is fixed, then x will be the limit. If y is changing, x is fixed, then y will be the limit. If both x and y are changing, then both will be limit. So this is the concept. So for our case, at this moment, we have x is seen to be changed. So that means limit will be for x, not for y. So what will be the lower limit? Try to understand. Is it 0 to 2 or 2 to 0? It will be 2 to 0. Do you understand my point? Because we have 2 and 0 to 2 is the lower limit. So obviously 2 0. Apparently it is looking that 0 is the lower limit and 2 is the upper limit. No. You have to think about the path. That is, you are coming from 2 to 0 to 0 2 point. You know that we can't actually draw complex function, that is z squared plus 3z, because for drawing for the graph of complex valued function we actually need 4 dimension, but in real life we don't have 4 dimension. So that's why the concept of mapping is coming, and you have learned the concept of mapping in your week 3 or week 4 contents. So that's why we are not focusing on the graph of z squared plus 3z, but we are focusing on the path that we have 2 to 0 2. So that's why instead of drawing this one, we are just figuring out what is the path. So here we have 2 to 0 2. So obviously 2 is in the lower limit position and 0 2 is in the upper limit position. So you will be confused why we are writing 2 0. Depending on the path, we are writing 2 is the lower limit and 0 is the upper limit. Is that okay?
Yes, sir.
Yeah, thank you. So now our target is to convert dz to dx because we have this time x. So for finding dz, always we have to start from z equal to x plus yi. So this is our base form. So we have z equal to x plus yi, and you know that we have the fixed value to y. So x plus 2i, we are keeping the fixed value here. Now this time we have to differentiate both sides in terms of x. So we are differentiating in terms of x. So from this part, we are getting dz dx equal to, so differentiation of x is 1, differentiation of 2i, that is a constant, that means 0. So we actually have finally 1. So that means our target is to find dz. So dz this time is equal to dx. So finally we are done. That means we can write this integral as, so previously we have 2 to 0 2 as the limits. Now we will have 2 to 0. That means these limits are for x equal to 2 to x equal to 0, z squared plus 3z, and dz will be dx. So gradually we are trying to simplify this complex valued function, and the
Sir,
integral is becoming easy. Yeah. Do you have any question?
should we not replace the z with like the way we did in the last math, replacing z plus?
Yeah, we have to do same thing again. And that means you are asking for this one.
Yes, sir.
Yeah, we will do here.
Sir, you wrote dx but did not replace. That's why I asked.
Okay, in next line I will do. So okay, so we have actually 2 to 0 2 z squared plus 3z dz, and now we can write it is from 2 to 0 dx. Okay, so we are sure that we are integrating this time in terms of x. So at this moment we have to convert z to x plus yi. So x plus yi squared 3 times x plus yi. So once we have mentioned x equal to 2, x equal to 0, in next level we don't need to write. We just can keep 2 to 0. So here we have the fixed value y equal to 2. So that means let's replace y with 2. So x plus 2i. Here we have 2. So now we can easily integrate. That is, it will be x squared plus 4x I plus 4 I squared 3x plus 6 I dx. So now we can write 2 to 0. After this simplification, what we can do? Here we have x squared plus 4xi. 4I squared, that is, it will be negative 4 because I squared, you know, it is negative 1. So we have 3x plus 6i dx. Now, whatever integral we have here, that is only for x, you can see, or constant. So that means we can easily integrate this integral. It is going with our previous course math 1 to 0. So that means focus on x squared, it will be x cubed over 3. 4I is constant. Integration of x is x squared by 2. 4 is constant. So integration of 4 will be 4x. 3x, it will be 3x squared by 2. 6i x. Upper limit 0, lower limit 2. Now we have to apply the fundamental theorem of calculus, that is antiderivative at upper limit. So for this we need to locate x. Here we need to input 0 at first, then we need to input 2. So at first, if we input 0, so 0, 0, 0, 0, 0, that means first part will be 0. Negative, antiderivative at upper limit, done. Now work with lower limit. So it will be 2 cubed by 3. That means where we have x, we are plugging 2. 4i 2 squared by 2. 4 times 2, 3. 2 squared by 2. 6i times 2. So now we have 8 over 3. And this calculation will be actually 8i negative 8 plus, here we will have 6 and 12i. Have I written the correct one?
Yes, sir.
Okay. So now we can add all these things and we can write our answer in a plus bi form. So let me do this one also. So here we have 8 by 3. Okay. 8 by 3, negative 8, positive 6. If I use my calculator, then it will be 8 over 3, negative 8, positive 6. It is actually 2 over 3. And 8i plus 12i, this is giving us 20i. So finally, negative 2 over 3, negative 20i, that is the result for this integral. So you can see that just for the change of the path, we have found this time a different result. But for the same integral, previously we have done this one, but the path is different. It is from 2 to 20 to 22. We have found another result. So this is the thing how we can solve complex integral. Is that okay? So I have already mentioned that a complex integral may be in these forms: f of z dz with c, or z integration from z1 to z2 f of z, or we have some points x1 y1 x2 y2. So this is how the complex integrals will be represented. Now let's move to the complicated ones. Suppose we have a complex integral where both that means both x and y are changing. So in that case, what we have to do? Let's say we have to evaluate the integral z bar, that is conjugate of z, It is conjugate of z. But at first, try to remember conjugate of z will be, if z equal to x plus yi, then z conjugate will be x negative yi. And the vice versa is also correct. That is, if we have z negative yi, then its conjugate will be z positive yi. So we have to integrate this one. We have a path, and the path is where c is the path or is the straight line. For now, let's work with a straight line. After this problem, we will move to some other functions. So c is the straight line from 0, 0 to 2, 2. So we have to evaluate this integral. So let's try to draw the path. So here we have 0, 0 point. This is 0, 0 point, and 1, 2, 1, 2. So this is 2, 2 point. So if we join this 2 point from 0, 0 to 2, 2. So that means from 0, 0 to 2, 2. This is the orientation. So this is our contour or path C. So whatever I am discussing here, that is the problem solving session. And if you have a look on the videos in BUX, so you will understand the theoretical part of this thing. Okay. So let's try to figure out at first what we can write here. We have C. So now we can mention the points 0, 0 to 2, 2. We have Z bar dz. So our first target is to find the limit. So step 1. Our points are 0, 0 and 2, 2. You can see x equal to 0 and y equal to 0 from the first point. And from the second point, we have x equal to 2, y equal to 2. So this time, have a look here. X equal to 0, x equal to 2. So x is changing. Y equal to 0, y equal to 2. Y is also changing. So in this case, both x and y can be the limit. Do you understand my point? If we take x as the limit, then 0 to 2 will be the limit. If we take y as the limit, so again, these values are same. It is 0 to 2. Okay. For now, let me change this one. Otherwise,
Sir, can we take any one of the two limits here, like either x or y?
yeah, we can take any one. Let's say it
Sir,
is
but
3. Yeah.
sir, but if they are different, I mean the numbers are different. Not in both the cases of x and y, it is not 0 to 2. For example, if in case of x it is 0 to 2, and if there is y, in case of y there is 0 to 5, then what will
Yeah,
be?
I am doing the same thing here. So instead of 2, 2, I am taking 2, 3. Is that okay now?
Yes, sir.
Okay. So now we have this. So it is now 2, 3. So y is also changing from 0 to 3. So okay. So since y is 0 and y is 3, that means y is changing. So if we take y, then limit will be 0 to 3. Do you understand my point at this part?
Yes, sir.
Okay. So limit is 0, 0 to 2, 3. Okay. So if we have both x and if we find both x and y are changing, that means both x and y can be the limit, but our target is to keep only for f of x dx or f of y dy. That is the thing I have discussed earlier at the very beginning of this session, that we have to keep either f of x or f of y form if we have f of z. So we can take any of the two, that is limit of x can be taken, y can also be taken. So it's up to you. You will get the same result. Okay, for this case you will get the same result, so no problem. So it's wise to we are very familiar with x, so we can also take x, or if you want you can take y. It's up to you. So suppose I am taking x. So x equal to, if we take x, then limits are here. Limit of x will be 0 to 2, and the function is z bar. We have dz. So since we have taken x, so dz should be converted anyhow to dx. Is that okay?
Yes, sir.
Or you can also verify your result by this. If we are want to work with y, then y will be 0 to y3 z bar dz. So this time dz will be converted to dy. So you can work with anyone, you will get the same result. So for now we are working with x. So let's try to find dz. So we have z equal to x plus yi, that is the base form. So yeah, this time there is a problem. I need to move to another page so that you can understand clearly. So try to understand the difference between the previous two problems. That is, whenever we are finding dz, we are inputting the fixed value, right? For this one.
Yes, sir.
And for the second problem, we have plugged the fixed value. Then we have differentiated. But in this case, we don't have any fixed value. Both x and y are changing. So this time, what we have to do, so this time we have to find the curve. Yeah, now we are moving to the complicated part. That means we are working with a straight line, but this time the straight line is not given. So we need to find the curve. So you know that our target is to convert dz to dx anyhow. So how we can do this? So this case is applicable if both x and y are changing. Try to understand this one. So we know that the straight line joining 2 points x1, y1 and x2, y2, from the concept of geometry, you know that the straight line will be x negative x1, x1 negative x2, y negative y1, y1 negative y2. Is that okay?
Yes, sir.
So here, let's say this is x1, y1, and it is x2, y2. So just input the values. X negative, x1 is 0, x1 0, x2 is 2. Try to input the values carefully. Y negative, y1, that is y negative 0, 0 negative, y2 is 3. So finally we are getting x by negative 2, y over negative 3. So we can write, okay, let me write here. We have 3x equal to 2y. That means y equal to 3x by 2. Is that okay? So the curve that we have here, see, that is actually representing a straight line, and the straight line is 3x by 2. So do you understand my point?
Yes, sir.
So I am going to find step 2. I'm going to work with step 2 now. So step 2. Our target is to convert dz to dx, because we have taken the limits of x. So in step 2, we have the base form z equal to x plus yi. So here x, now y will be converted to 3x by 2. Replace y with 3x by 2. Do you understand my point?
Yes, sir.
So this is the thing, this is the difference between the previous problem and this one. So now we can differentiate with respect to x. So ddx of x plus, let's say we can take the constant before and then x, 3i by 2x. So here we have 1, 3i by 2. So dz dx, our target is to find dz only. So dz equal to 1 plus 3i by 2 dx. So now try to understand, if we work with y, so here you have to keep x, right? So x equal to 2y by 3, then you have to input x here. So you can work with both x and y if both x and y are changing. Is that okay? But it is wise to work with x, because x is your known variable, because we are practicing from the very childhood with y equal to f of x, so x is very known. So that's why I have chosen x here. Is that okay? So now try to write again. I am trying to write again this one so that you will understand the basic things. So previously we have 0 0 to 2 3 z bar dz, and then we have found the limits x equal to 0, x equal to 2, z bar, and dz has been converted to 1 plus 3i by 2 dx. Okay, so let's work with this one now. So you can see that 1 plus 3i by 2, this is a complex number, this is acting as a constant. So we can pull this one before. Integration from x equal to 0 to x equal to 2, z bar. So now what will be for z bar? So 1 plus, you can write directly. If you understand clearly, you can write directly, no problem. So if z equal to x plus yi, then z bar, this function will be x negative yi, obviously. So it is x negative yi dx. So see, we are integrating in terms of x. So no y is allowed. So again, we have to replace y with this 3x by 2, because we have found y as 3x by 2. Do you understand my point?
Yes, sir.
So here we are getting 1 plus 3i by 2, integration from 0 to 2, x negative 3i over 2. Let me check again. Sorry, 3x over 2. It is 3x. 3x over 2 dx. So here we have 1 plus 3i by 2. Now we can integrate. So integration of x squared by 2. 3 by 2 is constant. So at first write this one. Integration of x again, it is x squared by 2. Or we can also simplify this one previously, so that if we subtract x with negative 3x, then we will 3 by 2x, then it will be 0 to 2 negative 1 by 2x. You can simplify at first. Do you understand my point?
Sir, why did the I of last line go when you put the value of y?
Oh, yeah. That's why something is looking weird. Thank you. Here we have I. We have just replaced y. So here we have I. Thank you. So here we have integration from 0 to 2. Now we can integrate. Yeah, thank you. Otherwise, there will be a big mistake. So here we have integration of x, that is x squared by 2. And here we have 3I by 2 is constant. Now integration of x is x squared by 2. Upper limit 2, lower limit 0. Is that okay now?
Yes, sir.
Okay, thank you. So here we have found already the antiderivative, that here we have 3I and in denominator we have 4x squared. Upper limit 2, lower limit 0. So before applying fundamental theorem of calculus, let's locate x so that we can input the upper limit and lower limit. So 1 plus 3I over 2. If we work with upper limit, so 2 squared by 2, negative 3I by 4, 2 squared. This is the working for upper limit, and for lower limit 0, it will be 0, negative 0. So finally 1 plus 3I by 2. And here we are getting 2, negative 3I. Is that okay?
Yes, sir.
So this is our answer. This is the acceptable answer. But sometimes there may be requirement that whatever answer you will find, convert this to a plus bi form. That means we need to multiply just this two complex number. Is that okay?
Sir, is it possible to do it in calculator?
Yeah. Now you are in week 6, so you can jump many things. Is that okay?
Yes, sir.
Because just to save your time in your final exam, this type of algebraic manipulations, you can do all these things in calculator. I am also doing the same thing in my calculator. Just wait, I am finding the result. You don't need to show all the steps here, but you have to show this one. What is the integration of x? What is the integration of 3i by 2x? So these are the minimum steps you have to show. Okay, so it is actually giving us 13 by 2. So 13 by 2 is actually looking real number, but you know that it is a complex number because 13 by 2 0. So clear?
Yes, sir.
Okay, so we have worked with 3 different problems. First problem is dealing with where x is changing. Second problem is y is changing, suppose, and the third problem is both x and y are changing. So when both x and y are changing, we need a curve y equal to 3x by 2 so that we can replace y or x by that curve or that function, so that we can find easily dz, and we can convert dz to our known variable dx or dy. Is that okay? So from this part, I would like to extend this idea with some other nonlinear curves. So far we are working with straight lines, but this time I'm going to work with some other curves. Is that okay?
Sir, Sir, we will find the equation of the curves only if the values of both x and y are changing, right?
If both x and y are changing and it is mentioned that you have been given a straight line, then you can find a straight line equation. Do
Sir,
you
whether it's
understand?
a straight line or parabola or whatever, will it
Yeah,
be simple?
since you have mentioned a parabola, so let's work with parabola. Okay. So we need to evaluate. We have still 1 hour. Let me think about a problem. Okay, let's say we have a problem. This time it is in the form f of xy, not f of z. We have x squared negative I y squared dz. And we have a curve C. So we need to evaluate this integral. You can see that this is actually f of z. If we simplify, we will get this one. So instead of f of z, that means previously whatever we have z bar, and then finally we are converting this one to x negative yi. So our problem is now in this form. Do you understand the problem at first? It is actually f of z. Do you understand this one?
Yes, sir.
So here, C, let's say C is the parabola. C is the parabola. Let's say y equal to 2x squared. That is coming from 1 to 2 to h point. Okay. The previous problem, this one can also be in alternative form. Instead of this 0 0 to 2 3, it may be where C is the straight line, y equal to 3x by 2. So if it is mentioned, then you don't need to show all the steps. Do you understand? So our problem may be in different alternative notations, but the solving technique is always same. So instead of this time a straight line, we have a curve y equal to 2x squared. So let's try to evaluate this integral. At first, one two. So 1 2. So here we have the first point, and 2 8 1 2 3 4 5 6 7 8. So 2 8 and 1 2. So we have a parabola. This time it is not a straight line, it is a parabola. Okay, at first try to understand how we can draw the graph. Do you know how to draw the graph? We have y equal to 2x squared. So we can input x. Let's say we can input 0 1 2. If we input 0, we will get 0. If we input 1, we will get 2. If we input 2, that means 4 times 2 8. So we are getting 0 0 1 2 2 8. So now we can draw that the exact figure. So 0 0 1 2 and 2 8 will be here. The more you take points, the graph will be more and more smooth. Do you understand my point? We have actually this parabola. If we take some other points in left side, we will get this type of parabola. Do you understand? Try to respond. Yeah. So we don't need to draw the total parabola, but our target is to just have the point. Sometimes in your question, there will be a requirement that draw the path, sketch the path, and evaluate the integral. So this is our point 1 to 8. So we don't need to extend this one here. Our target is to just find a path from 1 to 8. So you can see that from 1 to 8. So 1 2 is the starting point. 1 2 will be in the lower limit, and in upper limit we have 2 8. So x squared negative yi squared dz. So gradually we have replaced c by 1 to 8 point. This time remember, c is not the straight line, c is rather a parabola. Is that okay? So now we need to convert this function that is for x and y both, or we can say f of z. This function should be converted to either f of x or f of y so that calculations become easy. So let's figure out the limit at first. So step 1, in step 1 we have to find the limit. So we have the point 1 2 and 2 8. So here we have x equal to 1 and y equal to 2. X equal to 2 and y equal to 8 for the second point. So you can see that x equal to 1, x equal to 2. So x is not fixed, x is changing, or x varies from 1 to 2, whatever we can call. We can say change or vary. Okay. Similarly, y equal to 2, y equal to 8. Y is also changing. That means both x and y can be the limits. So if we take x, so 1 2 will be the limit. If we take y, then 2 8 will be the limit. Do you understand up to this part? So if you understand this one, thank you. So let's try to find dz, but at first be sure that with which variable you are going to integrate, x or y. It's up to you. But if we take x equal to 1 to 2, then integration will become easy. But if we take y, then you can see that 2x squared equal to y, then x squared equal to y by 2, then x equal to plus minus root over y by 2. So things will be complicated. So it's wise to use x for this case. Sometimes y limit will be convenient, sometimes x limit will be convenient, and sometimes both x and y limits will be convenient. Is that okay? So try to understand that this time we are going to take x, but we can also solve the integral for y, but that will be complicated than this one. So we are sure that this time we are going to take 1 and 2 as the limit. That means x will be the limit, 1 and 2. This is sure. So now z. So z equal to x plus yi, that is the base form, So here you can see that before finding, so since we have taken x as the limit, so dx should be converted to dx. So that means we have to replace y is given 2x squared I. So this is z. Now if we differentiate, can I write directly? dz we are differentiating in terms of z, in terms of x. So differentiation of x is 1, it will be 4x I, or we can write 4ix dx. Have you understood this part? I have written directly, or you can explain by this way. At first you were differentiating in terms of x, then you were transferring the x on the right side. This is the way how I have solved this one. Have you understood this one?
Yes, sir.
Okay, so we can now solve the integral that we have. So integration from 1 to 2, 2 to 8, x squared negative iy squared dz. In next equation we can write we are sure about the limit. We are going to take x equal to 1 to 2. So integration from x equal to 1 to x equal to 2, x squared negative I y squared, and dz is now 1 plus 4i x dx. 1 plus 4i x dx. Is that okay?
Yes, sir.
So here, this time, you can see that 1 plus 4ix, this is not constant because we have x. So whatever we have done for previous problem, 1 plus 3i by 2, since there is no x term here, that's why we have pulled out this one before the integral here. Do you understand? But since now we have x here, so we can't do that. This is a variable at this moment. Okay. So before integrating, we have one more task to do. That is, you can already guess. Y squared. We need to replace y as 2x squared because our target is to keep all the variables in x. So here, have I written the correct one? Yeah. So integration from 1 to 2, x squared negative I 4x to the power 4, 1 plus 4i x dx. Or if I write in convenient way, it will be 4i x to the power 4. That means we can use the parenthesis this. So we can't integrate at this moment because we have the product form. So what we can do, we can multiply at first. So at this moment calculator will not give us the solution. Okay, so at first we have to simplify, so we have to do manually. X squared times 1, that is x squared negative 4i x to the power 4, and then we have, if we multiply x squared times 4ix, it will be 4ix cube negative 16 I squared x to the power 5. Try to have a look closely. Is that okay? X squared negative 4i x to the power 4 plus 4i x cube. I squared is negative 1, so 16x to the power 5 dx. So now we can integrate because we have separated all these things and we have now summation subtraction terms, negative, positive, positive. So okay. Now integration of x squared is x cubed over 3. 4i x to the power 4, x power 5 over 5. 4i is constant, x to the power 3, x to the power 4 over 4. 16, x to the power 5, it will be x to the power 6 over 6. I am applying the power rule of integration. Is that okay?
Yes, sir.
So already our main part is done. Now we can see that here 4 can be cancelled and it will be 3 and it will be 8. So if we simplify, so we have x cubed over 3 negative 4i over 5 x to the power 5 plus I x to the power 4 8 over 3 x to the power 6 upper limit 2 lower limit 1. Now we can apply the fundamental theorem of calculus, but we need to locate where we have to input upper limit and lower limit. We have to input upper limit and lower limit where we have x. So let's do the same thing here. From this part, we are writing, we are working for upper limit. That means f of b minus f of a. If we have integration from a to b, f of x dx. So this is the fundamental theorem of calculus. First of all, let's work with upper limit. We have already found the antiderivative. 1 cubed by 3, that is 1 by 3, negative 4i over 5 times 1 power 5. So I am not writing, I am writing directly. Plus I 1 to the power 4, that is just I. Here we have 8 over 3. Okay, so we have found up to this one. So you can see that 2 to the power 5, 2 to the power 5 is actually 32 times 4. That means we have 128i by 5 for the second term. And here 2 to the power 4, that is 16i plus 2 to the power 6 times 8, that is 512 over 3. Okay, negative, we can add 1 over 3, 8 over 3. So 1 over 3 plus 8 over 3, that is equal to 3. And here we have negative 4 over 5 plus 1. I am adding this 2. So that means it will give us positive 1 over 5 I. Now we can add all these things. We will get the result. So 8 over 3 and 512 by 3. Let's add this 2. You should keep your answer in a plus b I, that means in standard form. So we have 520 by 3 negative. If we add this 2, that means negative 128 over 5 plus 16 equal to negative 48i over 5. So this is for the first part. negative 3 plus I by 5. So now we can add all these things. If we add 5, you can do this one in your calculator. So 48 over 5 I negative 3 plus I over 5. So finally we are getting 511 over 3 negative 49 over 5 I. So have you understood this one?
Yes, sir.
That means actually we have this time a parabola, and the parabola is coming from 1 2 point to 2 8 point. So from 1 2 to 2 8 we have to figure out the limit, since both x and y are changing. So both x and y can be the limit, but x has been taken so that we can easily calculate. So here step 1 is done. In step 2 we have replaced y as the function to x squared, and then we have evaluated dz. So dz is 1 plus 4i x dx, and now we are applying our basic integral technique to solve this integral. And finally we have found the result. Okay, so we have solved some problems, some 4 problems. First problem is dealing with where x is changing, then second one where y is changing, and the third and fourth one where both x and y are changing. But the fourth one has the special criteria that here the curve is parabola. So now let's do we have time so we can move to the next level? Can you hear me properly?
Yes, sir.
Okay, so already the basic parts are done. Now a complex integral, so this another part is coming. A complex integral may be in this form: f of xy dx plus f of xy dy, and we have the integral it may be z1 z2, or we may have the points x1 y1 x2 y2. So this is another type. Whatever type we have discussed so far, that is like this one: integration of f of z with respect to z, integration of f of z with z1 z2 as the limits, or we may have f of z x1 y1 x2 y2, or we may have this one and this one, meaning is same. But so you know how we can solve this one. Already you have the basic idea for this. But now whatever integral we have this one. This is another type. Is that okay?
Yes, sir.
So if we have this one, so how we can integrate or how we can evaluate this integral? So that is the question. Step 1 2 3, already you are familiar with the procedure.
So do we have more types?
Actually we have several types, but gradually you have to understand all the things. So we have another type, that is integration from x1 y1 to x2 y2, f of xy dx plus f of xy dy. So your problem will be also in this form, but the solving technique is same. But there is only one difference. You will understand the difference if we start a problem. Integration of 0 1 to 2 5, 3x plus y dx plus, let's say we have 2y negative x dy along the path, or let's say along the curve y equal to x squared plus 1. So we have to evaluate this one. So you can see that the problem is looking different from the previous problems, but actually the solving technique is same as before. We have just one difference in step 2, but all the problems are same. Actually, you will find all these things in your reference books. Let's try to solve this one. So our first target is to evaluate the limit. Our first target is to find the limit. So you can see that, you can see here the points that we have. Let's say this is step 1, 0 1 2 5. So okay, here we have x equal to 0, y equal to 1. For the second point, we have x equal to 2, y equal to 5. So you can see that x equal to 0, x equal to 2. So that means x is changing. Y equal to 1, y equal to 5. So y is also changing. So that means both x and y can be the limit. So if we take x as the limit, then limit will be 0 to 2. And if we take y as the limit, then it will be, you can see whatever we have done for previous problems. In step 2, we are working with z equal to x plus yi every time. Then we are replacing y to the function, or y to the fixed value, or x with fixed value. You can see our limit is 0 to 2, or our limit may be 1 to 5 if we take y. So we can take any of this. Let's work with x. So our function y equal to x squared plus 1 is given. You can see here we have dx dy, not dz. Do you understand my point?
Yes, sir.
Yes, sir.
Since we don't have dz, so that's why we don't need to work with z equal to x plus yy, and we are finding dz like previously. So we don't need this one. What we need? We need to find either dx or dy. So since we have taken x as the limit, we have chosen x as the limit. So that means we have to differentiate in terms of x. So we are getting dy dx. So differentiation of x squared is 2x, differentiation of 1 is 0. So finally dy is becoming 2x dx. That means our target is to convert this function that is in function for two variable xy. This should be converted to f of x. We can also convert to f of y. But since we have chosen x as the limit, it is up to our choice. You can take any of the two. Okay, but for our convenient part, we have taken x as the limit, because if we choose y, then it will be x squared plus 1 equal to y, then x squared equal to y negative 1, x will be plus minus root over y negative 1. So that is becoming complicated. So that's why it's wise to work with the convenient part. So here, now what we can do, we have the integral 0 1 to 5. So 0 1 2 5, I am again writing here 3x plus y dx, 2y negative x dy. So okay, here we have already figured out the limit. Limit will be x equal to 0 to 2, x equal to 0, x equal to 2, That means we are taking only x limit 0 to 2. Now 3x plus y dx to y negative x. Okay, let's replace dy. So dy is found as 2x dx. Do you understand my point?
Yes, sir.
Now you can see that our function is becoming f of x type. So only we have one task to do, that is here we can see y. So let's replace y as x squared plus 1 because this is our given function. So here integration from x equal to 0 to x equal to 2, 3x plus the function is x squared plus 1. So where we have y, we are plugging the function x squared plus 1. 2. Again, same thing will be done. y is x squared plus 1 negative x. And we have 2x dx. Okay. So now we have integration from 0 to 2. We don't need to write x equal to 0, x equal to 2 every time. Okay. So here we have 3x plus x squared plus 1 dx, 2x squared plus 2 negative x, 2x dx. Before integration, we can also simplify again. 3x plus x squared plus 1 dx. And if we multiply 2x squared and 2x, then it is becoming 4x cubed, 4x negative 2x squared dx. So we can integrate here, but we can also simplify before applying our basic integral skill. Okay, what we can do, simplification means you can see here we have 3x plus x squared plus 1 dx and some other part is here, so we can combine these two. 3x x plus x squared plus 1 plus 4x cubed plus 4x negative 2x squared dx. Can we do this?
Yes, sir.
Yeah. So here we have 4x cubed. Let's try to write order wise. So negative 2x squared positive x squared. It is becoming negative x squared. Now we have 4x, 3x, so plus 7x, and we have 1. So finally, we have one function for x cubed negative x squared plus 7x plus 1 that is coming from this big function. So it is looking very simple now. So this is the way how we can solve complex integral. So please try to keep eye on your BUX videos. Okay, you will get the theoretical knowledge and also some problems are there. Now let's integrate this one. Integration of x cube, that is x to the power 4 over 4, x squared, it is x cube over 3. Integration of 7x, so 7 is constant. It will be 7 x squared by 2. Integration of 1 is x, upper limit 2, lower limit 0. So we can simplify this. X to the power 4 negative x cube over 3 plus 7 by 2 x squared plus x. Now we can apply the fundamental theorem of calculus, where we have x, let's input upper limit and then lower limit. So 2 to the power 4, 2 power 3 by 3, 7 by 2, 2 squared plus 2 negative. If we input 0, 0, 0, 0, 0, so we are getting 0 here. Antiderivative at upper limit, negative antiderivative at lower limit. So 2 to the power 4 is nothing but 16. 8 over 3 plus it is becoming 2 times 7, that is 14 plus 2. So if we add all these things, we will get 88 over 3. So have you understood up to this part?
So
Yes,
can
sir.
you review the process in short?
I'm coming again. So we have now this form. We have to integrate this integral, but the function is in this form, f of x, y dx plus f of x, y dy, and the path is coming from xy1 to xy2. We have one problem here. Integration from 0, 1 to 5. We have the curve that is actually a parabola. You can see y equal to x squared plus 1. Under this curve, we have to evaluate this integral. It is of f of xy dx, f of xy dy. So what we can do in step 1, we have to check the x values and y values for the first point. So the first point is 0, 1. In lower limit, you can say 0, 1. So x equal to 0, y equal to 1. And the second point, that is the upper limit, is 2, 5. So here x equal to 2, y equal to 5. So the limit can be taken based on the concept that you can see here, x equal to 0, x equal to 2. So x values are changing, so x can be the limit. Y is also changing from 1 to 5, so y can be the limit. So but for our convenient, we can work with x. Our target is to convert this function of several variable to function of x only, or f of y only. So that's why what we have to do, we have to convert dy to dx. So that's for that case, we are differentiating in terms of x. Now we can replace dy with 2x dx. That's the thing I have done here. And y is given, y is x squared plus 1 in your question. So that's why I have replaced y as x squared plus 1. Now I have used just the simple algebraic manipulation and found this result. Is that
Sir, so
okay?
whatever is there in the question, we just have to turn everything into either x or everything into
Yeah.
either y.
Either f of x, either f of x dx or f of y dy. This is your first target. So we can solve another problem. So whatever we have discussed so far, we have solved about 5 problems. So now I am going to take a function. So we have to evaluate the integral. Let's say evaluate what we can say, evaluate real of z dz. Here, instead of lower limit, upper limit as points, we have a path c. C is like c1, let's say c2. Let me construct a problem. Let's say c1 ends at 1, 0. And c2 ends at 1, 2. Okay. So we need to evaluate this integral, where C consists of C1 and C2. So C equal to C1 plus C2. C consists of C1 and C2. So that means obviously C1 plus C2. So first of all, you have to find C1, and C1 is coming from 0, 0 to 1, 0, and then C2 will be from 1, 0 to 1, 2. The problem is actually same as before, but we have this time a path that is consisting of two paths. So we have to evaluate first integral, then another integral. Then if we add these two integrals, you will get the result. Do you understand the problem?
Yes, sir.
So we are moving to the advanced part, but the concept, the basic concept is same as before. So first of all, actually here we have two problems. From 0, 0 to 1, 0. You can see from 0, 0 to 1, 0, we have, based on the figure, we don't have any other information. We have a figure now. Based on this figure, you can see that C1 is a straight line. C2 is another straight line. Is that okay? Or C2 may be a parabola. No problem. But the concept is same as before. But I would like to highlight that some informations you have to gather from your figures to evaluate the integral. So that's why I have come up with this problem. So okay, let's try to solve this one. Let's try to rearrange the main function. Here we have real z. So you know that we know z equal to x plus yi. So real part of z actually x. If I ask you what is the imaginary part of z, that will be y. So since we have real z, so actually the integral that we have, that is actually giving us x dx, x dz. Do you understand what does it mean?
Yes, sir.
So this is our integral. Remember, this is equal to this one. We have to evaluate this integral. Okay, I have taken one simple problem here, but the concept is
So
here we have two parts. Yeah, any
sir,
problem? Yeah.
sir, so the question may come also in this way, right? That
Yeah,
there will be a
in
function
this
of z will be given, then we will have to find the real part of z, then
yeah.
insert it here.
Instead of this problem, if it is imaginary of z, then you have to use y here. Do you understand? You can also work with
Yes.
this. Okay, so since we have real of z as the function f of z, okay, so since we have two parts c1 and c2, so actually x dz c, that is the combination of c1 x dz and c2 x dz. Whenever you are finding your result, you can add these two, you will get the result. So c1 is coming from 0, 0 to 1, 0 based on this figure. So 0, 0 to 1, 0 x dz, 1, 0 to 1, 2, this is the path for c2. So 1, 0 to 1, 2 x dz. Is that okay?
Sir, are the points said in the question like 0, 0 to 1, 0, 1, 0?
Suppose you have a figure. Based on this figure, you have to understand. This figure will be given in your question with these values. So
Oh,
from
okay.
these values, you can understand what will be your path. So for our simplicity, we can write this is as this whole part as C, and let's say this is C1 and C2. So we are mentioning C1 as this and C2 is this. Total C will be C1 plus C2. So let's find C1 at first. So along C1. So in C1, you can see the points, that is the points are lower limit is 0, 0 and 1, 0. Upper limit is 1, 0. So 0, 0 to 1, 0. So let's figure out the values. X equal to 0, y equal to 0 for the first point. And here x equal to 1, y equal to 0 for the second point. So let's try to understand the chains. X equal to 0, x equal to 1. So x is changing. right? Y equal to 0, y equal to 0. Y is fixed. That means y is constant. So what will be the limit? X or y?
X.
Limit will be x. And the limit will be 0 to 1. So let's find C1 at first. So C1, you can see now C1 equal to 0, 1, sorry, 0, 0 to 1, 0 x dz. You can see from here we are working with C1. So here already we have understood that x equal to 0 is the limit, lower limit, and x equal to 1 is the upper limit, x dz. Now you can see we have taken the limit for x and the function is for x, but the only change that we need here, that is we have to convert dz to dx anyhow. That means step 1, this is our step 1. Can you figure out? This is our step 1. And step 2, step 2 is to find dz from z equal to x plus yi. So here input the fixed value. Fixed value is y, y is 0, so 0 I. That means actually you have z equal to x. So if we differentiate, we will get dz equal to dx. Directly I am writing. Okay, so that means dz will be converted to dx. So this is dx. Now we can easily solve this integral. Integration from 0 to 1 x dx, and you know the result. It is x squared by 2, upper limit 1, lower limit 0. So 1 by 2, negative 0 by 2, that means 1 by 2 is the result. So we have mentioned that this is C1. So C1, C1, it is coming, finally it's our C1. The result of C1 is 1 by 2. So first integral is done. Okay, let's input one equation number here. This is equation 1. So now along C2, 1, 0 to 1, 2. X equal to 1, y equal to 0, x equal to 1, y equal to 2. So this time you can see that x is fixed, y equal to 0, y equal to 2. So y is changing. So which will be the limit?
Y.
Y.
0 to 2.
0 to 2. So we have 0 to 2 as the limit. That means 0 to 2. So our C2 is this one, this integral. We have already found the solution for this one, and now we have to solve this. 1, 0 to 1 to x dz. So C2 equal to 1, 0 to 1 to dz. Now we have already understood that this time limit will be for C2, limit will be y. So y equal to 0 to y equal to 2. And here we have x. So at first, for now, let's write x and dz. Okay. So since we have found y as the limit, don't forget the base form or step. This is step 1. And step 2, here we have z equal to x plus yi. At first input the fixed value. Fixed value is x equal to 1. This is plus yi. So this is z. So if I differentiate in terms of y, this time since I am going to differentiate in terms of, I am going to integrate in terms of y, so we have to differentiate in terms of y. So dy of 1 plus yi. So that means we are getting dz dy. What will be the result here? Differentiation of 1 is 0. Differentiation of yi is I. If we convert this on right side, transfer this on right side, then we will get dz equal to I dy. Is that okay?
Yes, sir.
So now we can write C2 as integration from y equal to 0 to y equal to 2. You can see x. So already we have the fixed value of x because we can't keep x here because we are going to integrate in terms of y. So let's input the fixed value 1. And dz is found to be I dy. So finally done. That means I is constant. Let's pull out I before integration from 0 to 2 1 dy. So integration of 1 in terms of y will be y. So 2 0. So if we apply fundamental theorem of calculus, we will get 2i. So this is C2. So from equation 1, our target is to evaluate the whole integral for the total path C, and we have already made an equation that C is equal to C1 plus C2. So C1 is 1 by 2, and C2, we have found C2 as 2i. So from equation 1, C equal to C1 plus C2. So what's the value of C1? It's 1 by 2. Yeah. And C2 is 2i. So we should keep our result in a plus bi form. This is a plus bi or x plus yi. So this is our total result. The integral that was previously real z dz. That means integration of real z dz for this part C is equal to 1 by 2 plus 2i. Thank you.